Test. Okay. Okay. Thank you for coming. Before we start, I want to ask you a few questions. I'm wondering why you guys come here. Is anyone come here because of the word of simplifying? No? Anyone comes here because of RxJava? Rx? Oh. Anyone comes because of my name? No? Okay. Oh, okay. I got you. Thank you. So today I'm going to talk about how you can simplify your code with RxJava. But before that, I have two challenges here. First is because it's so noisy, and second is because I have a broken English. So please bear with me. I hope I can give some value added to your knowledge on this. Before I start, I'd like to ask you a few things. How many of you here knows about category theory? No? How many of you knows about monads? No? Oh, you know. Okay, that's good. I have to be careful here. How many of you knows about side effect? Okay, good. So how many of you knows about pure functional programming called Haskell? Okay. Great. Because I'm not going to talk about that. It's complex, but it's good that if you know that, because it's a basic of reactive programming here. Okay. I'm going to start with the so boring slides, which is the first one is about, I'm going to talk about what is Video SDK. So what is Video SDK? So, okay, my name is Ferry. I'm working in Yahoo. I'm working on Video SDK team, and basically Video SDK is a library. It's a library of the video player, a wrapper. We use ExoPlayer as a video player, and the purpose of it is just to make it easier for other apps to integrate with Yahoo Video. So the apps doesn't need to think about how to get the data for Yahoo Video, how to play the ads, whether it's a pre-roll, mid-roll, post-roll. So it doesn't need to think about that. Sorry. The second thing is what we have in Video SDK is we have a lot of components. Remote API call, instrumentations, UI, UX, to the company brand, and also error handling. Today, I'm just going to focus on two things, which is the UI, UX, and the error handling. Okay? It's not the fully error handling. The error handling that is very specific to the video player. Okay, so this is the first requirement comes from the, let's say, comes from an architect. And this is a very generic requirement when you write a video player, which is they will ask you to, can you build a video player that according to the company brand, and please update the sidebar UI whenever the video plays, and stop the sidebar whenever it pauses. And then the second thing, to make it more robust, can you detect inactivity? Let's say if you come to the previous talk about the video player, in video player, you always have a problem where the video gets stuck. So we want to be able to detect that and then do something about it, which is normally what the user do, which is it try to reload the video, or you go and refresh. So this is a sequence diagram. I trust you guys are very familiar with this. So what's the problem with this sequence diagram? I'll show you the problems. The first one is start and stop. So what's the problem with that? Okay, and then the second one is the frozens. Tell you what's the problem. The problem is here the player try to manage the clock. So what do we use the clock for? So basically the clock is used to, I call the video player and I got the current positions and then update the UI. Very simple. And you need someone to start the clock. So you have a controller here. You tell the player to start the clock, and then the clock start running, and it will update the UI every second. The problem here is the big question here: why does the player need to know about clock? He shouldn't know anything about clock. You are adding one more responsibility to the player. Okay. So maybe we can do a little bit of refactoring here by, okay, maybe the player doesn't need to know about clock. How about we build a listener implement the listener on the clock. That's also a bad idea because player itself have a lot of events. So you can think of on player, you can have on initializing, on playing, on player, on pause, on buffer start, on buffer stop. Why should the clock need to know all these things? It doesn't make sense. And it makes your code ugly. The second thing is about frozen. For you to detect a frozen, you need to maintain a state. So let's say you think about, oh, okay, I'm going to maintain the state at the clock. Okay, it becomes a shared state maybe, something that someone might accidentally updating it. That's something that you don't want as well. And then the frozen detections need to depends on the player state, which is when it pauses, you don't detect that as a frozen, right? It's supposed to be, the video is supposed to be stopped. So it's expected. So the second requirement is so simple. Your architect come to you, hey, I have a simple requirement. Can you detect if the video does not play within X seconds, do something about it. It's so simple, right? Why it takes it to you so hard? Why do we need these features? We need these features mostly in the ads. So what does it do is, we detect if the ads does not start within, like, let's say, 5 seconds, we just want to show the content. We want to have a great user experience. It's so simple. The architect tells us it's so simple. And then we need to implement this. But when we try to implement this, we know it's not that simple. So normally what we can do to detect whether the video play or not, we add a timer. And then after we add the timer, we tell the timer, can you check? If no one's tell you that the video playing after 5 seconds, can you tell the controller or something that video is not playing? So what's the problem with this diagram? Okay, so the problem is, again, start and stop. And if you see, the problem here is the timer is managed by two parties, which is the controller and the listener. So listener here is actually the player listener. Player listener is basically saying that, oh, now I'm playing. Okay, listener say, okay, now you're playing. Then I need to tell the timer, stop. Okay, we are playing, we are good. Okay, but can you start to see the problem here? You try to update a shared state. It is a mutable state. We all know that this is a problem. So because we doing that, here's what happens. We create a God object. What is a God object? God object is the object that knows everything, that maintains everything. So the first time when I got the code here is like, they have one single God object that is so important that you cannot do unit testing on it, and it will just getting bigger. Every time we want to add a new functions, a new method, a new event, here is the God object. If you want to add ads, you need to tell the God object, hey, there is a ads object here. You want to add instrumentations, instrumentation is managed by the God object because instrumentation is accessed by all the other objects. So I can talk a lot of things about this, what happens, but this is not the real pictures of what is the relationship between all these objects. It's so complicated. And that's the thing. Nobody knows what it does. Nobody there to change the code. Okay? He lives as a God. So the question is, can we simplify? So how do I came across with RxJava? So when I got this code, I have a very ideal thinking. I'm going to refactor this. What he did is wrong. It could be better. Then I tried to refactor it. The first time I tried to do is I'm using event bus. Event bus is good. But if you think about event bus again, event bus is actually a global variable. You're just replacing another God, right? So I'm halfway done it, and I'm not happy with the code. So while I'm doing the research of using event bus, there's an article saying that, you know what? I'm using RxJava, and I never look back. But I ignore at the time. I don't want to see that. I take a look at RxJava. Oh, it's so complicated. Then, because in Yahoo we have to tell if you want to use a new library. So there are two library event bus that is pretty popular. One is Greenbot, the other one is Okta or something. Then I check with there's an iList, the mailing list group there. And then there's one architect saying that, you know what, I'm using RxJava and we never look back. Okay, so maybe that's the answer. So I spent a lot of time understanding what RxJava is, a few weeks. Yeah, I kind of know what to do. I kind of know how it works, but I don't know how to use it. So let me tell you a story about what happened yesterday. So yesterday I come to Droidcon, and then I carpooling with other two Yahoo, which is they are the recruiter. One is Joseph, one is Dan. So Joseph asked me, so Ferry, what are you going to talk about? I said RxJava. What is RxJava? Can you tell me a little bit about it? I said, I tell everything about RxJava, that what he hears is blah, 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 blah. Okay, Ferry. Then I said, do you get it? Kind of. Then I said, oh, I'm in deep trouble. If you don't get it, I cannot make my audience to get it. And then in the evening, we went back home. And then there's this guy we are talking about, because it's a long trip from San Francisco to South Bay, we started sharing our personal, what we want to do. So one of the guys said, hey, I want to open a restaurant. Dan said, I want to open a restaurant. And then he said that, I have 6 years working in restaurants. You know what I do? I know everything about restaurants. Let's say if someone order a shrimp pasta, I will tell one guy to, okay, heat up the shrimp, put a salt in it, and then can you start cooking the pasta? And then after that, he will make the pasta, shrimp pasta. Then I said, that is Rx. That's what you're doing with Rx. That's what Rx can do. Then he laughed, and he said that, let me do the presentation tomorrow. But he didn't come today. Okay? So that's how I explain Rx, reactive extensions. So I kind of struggle on how to explain Rx. But the funny thing is, the source that can explain about Rx is actually from the site itself. So what they told you is reactive extension is the observer pattern done right. It's kind of vague, and this is come from reactive I/O. But what mostly hit me is the detail of here. ReactiveX is a combination of the best idea from observer, iterator, and functional programming. Okay, I'll go through one by one, and why does it make sense? Observer. So, anyone here doesn't know about observer pattern? Oh, okay, we got one. Okay, so let me explain to you. So here how we do code before. We have a pull mechanism and we have a push mechanisms. So what observer did is moving you from pull to push. So what does pull means? Pulls mostly in the synchronizations, a synchronized method call. What does it mean? It means that if you think about the sample before, hey, can you prepare the stream, the salty streams? Then you will wait. After you get the stream back, then you tell another guy, can you make the pasta? Okay, it's not really efficient. You are slow. Okay, and then the push basically telling that, can you make exactly what the sample is? Make the stream, and then can you make the pasta? And then you tell me, and then I will join it. So this is the observer pattern. The second thing is iterator. Iterator is basically how you do a multi-value, and then on the observers, what they lack of is they don't have these functions, on next and on complete. If you think that this is not important, it is very, very important in the Rx. In the reactive programming, this is very important. I cannot explain you in the details, but when you see the sample, you can understand why is it important. So the third one is the functional programming. Why do you need a functional programming? Before I start with the functional programming, anyone knows about JavaScript promise? Okay, great. So JavaScript promise is, I can say, is functional programming. So what does functional programming allow us to do? Basically, we saying that we can build complexity out of simplicity by using compositions. So I want you guys to remember here is the compositions. Okay. So when you do a promise object in JavaScript, you are able to do compositions. Do something when. But what promise lack of? I'm not using promise, so I could be wrong. Correct me if I'm wrong. What they don't have is the iterator functions. Okay. If anyone asks about Rx versus promise, from my observations is they don't have the iterator functions. Okay. So this is how normally we do code. We do it imperatively. Okay, I took this sample from Haskell tutorial page. Let me ask you, what's wrong with these functions? Okay, so there's nothing wrong with these functions, but from the Haskell engineer point of view, it's like you kind of mix two operations here, which is the first one is you multiply 3 to its content, and then the second one is you sum it up. Did you see here? So from the Haskell engineer point of view, hey, you're mixing a complexity here. We can make it more simple. And in Haskell, this is how you do it. You say sum, pass the functions, and then you iterate through. And they're also talking about indexities, which is basically you need to remember the index positions. That also, from the functional programming engineer, that's also problems. So if you can see here, I try to make the parallel, Haskell and RxJava here, is you can see in RxJava, we can express it using a similar functions. We can call some integer from the list, and then you map it, and then you times 3. Okay? So why is it so important to do compositions? I would say it will be less error prone. Why? Because when you do it imperatively, it will be the same like if I ask you guys to draw me a circle. Okay, some of you will draw the circle clockwise, some of you will draw the circle anti-clockwise. And what does it mean? It means to write one function, there are many ways. And if you are a less experienced engineer, you might do it not as robust or as beautiful as the more experienced engineer. And what Rx do for you, it gives you a set of operator, which is your vocabulary, and you can only have you are bounded by that vocabulary. Of course, if you attend the talk by Dan yesterday, which is very good, you can build your own operator, you can build your own subscriber or even the threading, but it's very rarely you doing that. So with the 3 functions, this is what we have. We have create, operator. You can say, I'm going to do this, I'm going to do this. This is the composition functions. And then you have a subscribe functions. And then basically you can do what you want to do when there's a next event happens, what you want to do when there's an error happens, and what you want to do when there's an on-complete. So normally what people do, they only implement on next or an on error. I would recommend you to implement on error even it's just a logging. Because it's in Android, if you don't implement, no matter how confident you are with your code, just put it there. Because if not, then it will crash the applications. Okay, I know you guys waiting like how to see the code, how Rx solve the problems here. Okay, before that, I will use the term here. It's hard for me to pronounce observables, and I think if I use the word topic, it's much more relevant here. Okay, topic. If you think about topic is something that I can subscribe, and it's a topic is very specific. Okay, it's not a general. What I'm going to say about this. Okay, the first one is, if you remember how we update the UI. Okay, I think I'm okay. Okay, So we try to solve the problem player and clock. So as in the first slide, I argue that why does the player need to know about clock? If I make the clock that knows about player as a listener, he needs to implement all the listener method. So this is one of the solutions. So you create two topics here, playing and pause. I'm only take two examples, playing and pause. Okay, and then the clock subscribe, and then I'm gonna go into detail here later. I think I give her, okay. I think the sequence diagram is wrong. So this is the final objective. I give you the final objective first. So if you can see there are 4 topics here. Okay, this is the design that we are trying to reach. Okay, so bear with me, sorry. Okay, so before we can do that, we have a player. The first thing we have to do is we create an observable media player. How do we create an observable media player? This is like a big question here. Like from you that start to learn about reactive programming, it takes you a while to find out like, I have an object here. Yeah, I have an object. How to convert it to become observable? You can use just, you can use from, like the sample that was given yesterday, but for media player, a little bit different. The talk say that don't use create because this, unless it's the last effort. Then I was thinking that this is the last effort. So this is the most complex code that you will ever see today. Here it is, I promise you. After that, everything is so simple. There's nothing magic here. It's basically I create a listener. I create a listener here. And then I set the listener to the player. Then the last part is what I want to do when it's unsubscribed. Sorry, it's a little bit too fast. If you see here, I implement the call functions, which is the interface of unsubscribe. Basically, what it's trying to do here is, what do you want to do when someone subscribes to your observable? Okay. What do you want to do when you put a subscriber to your observables? This is what I want to do. When someone subscribes it, I want to start listening to the player. It's just that simple. I want to start listening to that player. And when someone unsubscribes it, I don't want to listen to any player event. Okay, it's simple. The on next here is nothing but I call. If you see here, the on playing implementation is called on next subscriber playing, which is the on next is basically a function like basically I call the subscriber and I passing the event. There's no magic here. The player, when it plays, it will fire an event here, and the event will call the subscriber on next. No magic. Okay, this is the player event listener. What I have done here, after I create an observable media player, it allows me to create topics. Okay, it's simple. Okay, now I have a topic called prepare, playing, and pause. Did you start to see the separations here? Remember the two? Okay, I'll stop talking about the media player, then I'll go back later. So there's nothing magic here. After you know how to create the media observable, now you can start to create topic that you want. And the topic is composable. Okay, the second one is I need a playback clock. This is clock. Nothing magic here. It's basically saying that this clock will trigger an event every X seconds or every X millisecond, whatever you specify it. The sample here basically saying that please trigger the event every 1 second. And what you are doing here is basically getting the media player positions. If you understand, the map function is basically convert the data, which is the A long, which we don't care what it is. And basically what we want is like, we get the current positions of the media player. I'm not talking about the publish. Publish is basically a connectable observables. It was Dan already explained to you guys yesterday, but that's something not important here. What I want you guys to see here is basically the playback clock is getting the positions for every seconds. Did you see the composition start? Timer with interval 1 second, and then you map it to playback positions. Now, the next question is, how do you manage the clock life cycles? Why do we need to manage the clock life cycles? Because if you remember before, we have a requirement whereby when it pauses, don't detect it as a frozen, because that's expected. What it means that when the player is paused, the clock also needs to stop. Okay, this is you start creating a dependency here, but the dependency is not depends on the player. The dependency depends on the topic. If you see this clock subscribe to the topic, which is playing and pause, and if you see the implementation here, when playing, I start the clock observable.connect. So this is when you have a connectable observable. When you say connect, it means I start listening. Okay, so maybe it will help. I'll give you a little bit illustrations. So this illustration comes from the author of RxJava. If you think about observable and subscribe functions, think about the pipes. You put all the pipes. Once you are ready, when you want to turn it on, you subscribe it. Then all the water start flowing. Think about it. For connectable observables, is this it will on when you turn the knob means that you connect it. Okay, and then the second code is basically saying that when it pause or when the play complete, because we don't want the play complete and you detect it as a frozen, or it's release. So release basically just an internal. Basically we no longer want to use the media player. Call this mSubscriptions.unsubscribe. It means that I don't want to listen anymore. This basically will stop the clock observable from executing the interval. Okay, am I confused, you guys? Really? Okay, let me try it one more time. Let me get back to the topic. How about these slides? Is it very clear? You create an observables. Once you create an observables, you can start to create topics. Okay, I see a note here, so I can move on. Now I have a clock. The clock basically emitted every 1 second. And basically what it did is, what is your position? What is your positions? That's what it emits. Okay, now I need to manage the clock life cycle. Clock life cycle should depend on the player state, but I don't want to create a relationship to the player. I just want to create the relationship to the topic. Okay, this is like separation of concerns. It's not player concerns to manage the clock life cycles. Clock life cycle should be managed by the topic. By the topic that is interested to. So this code is basically playing. When it plays, start the clock. Observable.merge, basically like either or, pause, play complete, release, then stop the clock. Got it? Okay, cool. Thank you. So the next step is, this is something that we want, right? When the position change, I call it a change topic, you want to update the UI. When it's frozen, you want to tell the controller something goes wrong. Do something about this. Okay? How do we do that? So this is basically what I'm trying to show you. Topics are composable. This is the biggest the significant features of reactive programming, compositions, they borrow from functional programming. If you can see here, you see the source is the same. Timer every 1 second. Then I map it to playback positions. Then I want to compose a topic called change. I call it distinct. It becomes the change. I'll show you the code later. And then for frozens, Basically, I do some calculations. Oh, it's frozen now. But I'm only interested in when it frozens more than X seconds. I don't want to, it just stop for like 1 second. Maybe it's buffering or something, then I already like call it as emergency. No. Okay, I'll show you what we are doing with here. So again, back to the clock again. This is the interval, map the current positions, and this is how you say that, this is how you compose it to say that change, when the position is changed. You call the operator called distinct until changed. What does it mean? It means that it will not propagate the events to the subscriber if it does not change. So simple. Okay. And then whoever interested to this is, then they will subscribe and do something about it. Maybe it's not the UI that interested in this. We use it for like at beaconing, where we fire every 25%. We also using similar like this, but we compose on top of change. Okay. So you start to see the power here. So you have the change. You only propagate the events down to the subscriber when there's a changes. Okay, the second one is the frozen. So frozen, basically using the same source, which is the clock observables. You calculate the frozen time, okay, and then you filter, okay. Only when the frozen time is, let's say we specify, if it gets stuck for 30 seconds, then I will propagate the event down to the subscriber. Basically, this is what it's saying. Boom, you have the frozen.subscribe. And then you can bring these frozens anywhere. Anyone who is interested to these frozens, they can just subscribe to this frozen. Anyone that is interested in this topic, they can just subscribe and do something about it. Right? Okay. So it will be fair for me to show what is calculate frozen time. So calculate frozen times, if you see here, I couldn't find a better way how to specify frozen time other than start to introducing the state here. Mutable state, it's okay for me as long as it's not shared. Try to avoid shared mutable state. It won't do you any good. You will get confused. Who's updating this? Can we change this? What is the state at this point of time? You have no idea. But when you have an internal state where you maintain it by yourself, you can be sure that what's the state at this point of time. Because nobody can access this. So in Rx, it allows you to have, it's a normal object or normal class of function one. You can specify. This code basically nothing but checking the current playtime. If the playtime is equals, then you start to increment the frozen time. If it's not, then you just reset the frozen time to 0. After this, after the map, if you see, the code is very clean. After the map basically calling these functions, and then after that, it called the filter, and then the filter basically compare, okay, this is how long I've been frozen, and this is the grace period. Is it more than grace period? If yes, then I'm going to propagate the event. It's that simple, yeah. Yes. Okay, so the question is, okay, gotcha. Okay, so the question is there any type safety here? So I apologize. So when I write this, for the sake of concise, I'm using a lambda expressions. So the Java knows about what's the type at this point of time. Okay. So if you learn about functional programming, they only allow you to pass one parameters. Okay, one more time. We still have, I'm going to show you the beauty of compositions. We still have one more requirement, which is make sure it plays in X seconds. Who is the bad guy here? Timer. If you guys ever code using timer, you know how difficult it is to manage timer. You can start it, and you expect someone to turn it off. At one time, you are not sure that whether the timer has been stopped or not. You keep calling, hey, stop. Are you stopped now? Are you stopped now? Are you stopped now? So if he's the bad guy, Rx can help you to remove the timer. So again, think about compositions. So this is the final stage that we want to achieve. Prepare and release is basically indications that the player has started to, the video has started to play. Okay. This is just an internal definition. Release means I'm no longer interested in this video. Someone call that stop the media player, release it. Okay. I'm going to go through one by this. So the first one is I create a function called should start play in. Then I need to create a new topic here. The new topic here is definitions of play. What's the definition of play here? Which is prepared and release. No, sorry, not and. Prepared or release. We can use the merge operator here. It is basically saying that it's either the player fire a prepare event or the player fire a release event, then it satisfies these conditions. Okay. The next one is I introduce you a new operator called first. If you remember, I talked about the why iterator is so important. If you remember the on next and on complete, this is why it's important. So first means that whichever, sorry, let me get back to merge first. Merge will fire the events from whichever topic. Okay, you can use merge for any observables. You can join, but merge normally expect the same data type. So you can expect whichever of this topic fire an event. Then the first will get it, and it will start to fire on complete. This is very important. Okay, I'll tell you why later. So the first will fire on complete. I'm not showing you marble diagram here, but trust me. So first will fire on complete. And why is it important? Is because the second operator, which is the timeout. So timeout basically waiting for someone to fire the on complete. If the on complete event is never fired, timeout will always trigger an error. Did you see? For those you guys that use a promise, you don't have these features. You don't have the iterator mindset, which is you will iterate through and then you have a complete event. So three things that is important in Rx, which is observable, which is allow you to create a subscribe, allow you to do an asynchronous call, and then iterator helps you to allow you to use on next, on complete, and the last one is functional programming, which allows you to do compositions. And then the last one is basically saying that do nothing. I mean, if it plays in X seconds, basically do nothing. So if you see here the subscribe, no actions required. And do something when the timeout is triggered. Do you guys follow? So basically, this is you kind of know like how do you compose it. And as I said before, that reactive programming introduced a more declarative way on how you do programming. Okay, it's kind of hard at the first time, but when you get used to it, when you get it, it's very, very powerful. It allows you to, let's see, you remove the timer, you don't need to write a lot of code, and then you only have a set of vocabulary, which is the operator, and I don't see any a lot of variant of doing this. Okay. Okay. So either you are a very experienced engineer or less experienced, but if you guys know how to use Rx, you will end up to writing the same code, similar code. And then the other best part is Rx is implemented in multiple languages. You can easily jump to other language, and then use the same operator and get the same effect. So it's really look that simple, right? Questions? Oh, thank you. Yes. Yeah.
Thanks for the presentation. And the question is, how do you share the observables in your app, or whatever? Like, how do you share that state? I guess.
Oh, okay. That's where the design pattern need to come. Like, how do I share? So I kind of have a callback. Okay, so let me share about how the video SDK. So the video SDK will create the player on the fly. So I have a callback when the video player is being created. I call, I have to show you the code. So basically you need to figure out a way how to pass around but don't make it as a global object. You cannot inject, if you use dependency injections, you cannot inject observables here. So you create, and then for some reason you need to find a way like how to pass it. But still your code is clean. And then when you pass, the good thing about this is when you pass a topic. And you don't even need to know what is the source, or you don't even need to know the real object. Like you don't even need to know the player. Okay, I give you an example of what we do with the add beaconing. He doesn't even know that this is a player. What he got is a change topic. Then he composed to it. Oh, this one is being called every second. But what I want is the length of adds, and then I divide it by four, and then I fire the event if it's for every quarter. But there is a way to pass it.
I mean, why wouldn't you use dependency injection?
Why would I don't think you can. Okay.
Is it because you don't have to create an observable, you already need some kind of state, or I mean?
No, because okay, some observable is you only create it during runtime. Okay. Let me think. Yeah, I think if you use Dagger basically the constructor, and then you can implement the observable there, and then you can call it. But you have to make sure that do you really want to share the observable or not? Yeah, sorry, I take my word. Yeah,
okay,
right.
Thanks.
Thank you. Any more questions? Oh.
So as you're mentioning topics, I'm completely new to RxJava. I'm just wondering, are topics an actual part of the syntax of RxJava, or is that just more like a design pattern that or a concept that you're using?
Yeah. Okay. So topic is my own word, but I think it helps you to understand like, oh, this is a topic. Like when let's say you have magazines, you only read the magazine that you choose, right? Depends on the topic. Okay. So if I think I'm interested in topic, I'm gonna read, I'm gonna subscribe to it. So think about the topic, and what I'm trying to say is you can compose the topic and you can change the topic along the way. It takes a while for you to kind of change your paradigm, but think about how do I create topic, and instead of passing the object around, you just pass a topic. Once you pass the topic, there's no way you can change the state of the object. Right? It hides you from updating the object itself. Yeah. More questions?